So this first skill is not asking you to solve for anything. It's asking you to read these situations, kind of internalize the concepts that are being tested and the formulas, and figure out, do these make sense and will these situations occur? So do you really understand the gas laws? Not just plugging and chugging in numbers. You can pick out formulas, though, to help you understand them if you're having a difficult time grasping it. So let's look at this first one. How many of these changes will result in an increase in the pressure from P to P3 times 3? So 3 times the pressure. If I look at my answer choices, I see it's talking about moles, temperature, volume, temperature again, and volume. So all of these things can most likely be related in the ideal gas law, right? So then it's essentially saying, if pressure's 1 right now, what would make pressure become 3? So pressure equals nRT over volume. And I'll reference this as we go through the answer choices to kind of figure out, okay, would that triple pressure? Does that make sense? All right. If it only talks about one thing being increased or decreased, let's assume that the other things are staying constant, so we're not changing too many variables. So right here, if I increase the moles of gas from N to 3N, so if this was 1, and then you know what R equals, you can pick whatever numbers you want for temperature if you want to solve it. And now we're going to change N from 1 to 3. Well, aren't these all the same in both scenarios? So if the moles goes from 1 to 3, would that triple the pressure from 1 to 3? And that should make sense. That's what Avogadro talked about. Increase the number of moles of something, you can increase the pressure. Comes from page 252. He also talked about volume. Moles and pressure are directly related. Right? Anytime you add more of something, pressure should go up. As far as gases go, take away something, pressure should go down. Okay, what if we raise the temperature from 1 degree Celsius to 3 degrees Celsius? Remember, temperature should be in kelvins right here. So this is like 274 kelvins to 276 kelvins. Would that really change the pressure? So if you want it, you can plug in whatever numbers you want for N and V as long as it's constant in R. Plug in your 2 temperatures and see what happens to pressure. Does that go up by a factor of 3? And when you do that, it will not work. The next one says, what if we increase the volume from V to 3V? So increasing it by a factor of 3. So this would be 1. And then we're going to go ahead and divide it by 3V, or 3. Well, when you divide by a larger number, what happens? It makes the answer smaller. So it wouldn't increase pressure to 3. It would actually bring it down. So this one doesn't make sense. And the last one, what if you change V to half of that? So if that changes to half, this should definitely go up. But you also change temperature from 100 to 150 kelvins. So if you want, we could plug in numbers this time because we're changing a bunch of things. So let's say pressure for the first situation where we go I'm going to plug in 1 for V and 100 for kelvins. N's going to stay the same, so I don't know, I'll just pick 1 R 100, and then I'll say volume is 1. Okay, R is 0.0821, I just didn't feel like writing it out. The second situation, pressure equals, mole should be the same, R should be the same, temperature's 150 this time. Volume 2 will be 0.5 because it's half of that. Let's get our 2 answers and let's see, did pressure actually go up by a factor of 3? And so these are our two answers when we plug in the numbers from the situation. From here to here, it did increase by a factor of 3. So this one makes sense. So 2. Okay, I'll do one more with you, and then remember I'll have the solutions on Moodle so that you can kind of see how I worked them out and compare to your answers. So, I don't know, I kind of took up some room here, so let's go down to this one, this very last one. Alright, so what happens when the volume of a gas is increased at constant temperature? So temperature's staying the same, right? And we're taking volume, whatever it may be, and then whenever it changes, that volume is increasing. And it doesn't say by what factor. So we're going to go ahead and figure out which one of these makes the most sense. If volume goes up, pressure decreases because frequency of collisions with the wall decreases. So envision a gas, right? Let's say we have 3 molecules, 1, 2, 3. And then we take that gas and we increase the volume and we still have 3 molecules. Are these 3, the same from over here, but bigger volume, going to be hitting the container wall as often as when they were in half the volume? No. So if they're not hitting the container wall and they're not colliding as often, pressure should go down. So when volume goes up, pressure goes down, and Boyle said that. So this is our answer. But let's go through and look at the others. Pressure increases. Nope. And they also wouldn't be moving faster. Temperature's staying the same. Pressure decreases. That makes sense because molecules are moving slower. Well, they won't be moving slower because temperature's staying the same. They're moving the same speed. They're just not colliding as much. Pressure increases, so we just proved that's incorrect. We can get rid of that one. Pressure does not change because it's not affected by volume. Well, that goes against Boyle's law. We know that's not true. So I want you to go through the rest of skill 1. There's only a few questions. Analyze them, come up with your answers, and then compare to my answer key. Email me if you have questions.